Alright, so we're making another video here on simplifying radical expressions, and we're going to do two things here. We're going to take a look at fractions underneath radical signs, and we are also going to rationalize the denominator. And when I say rationalize the denominator, that means get rid of any radicals that are in the denominator. We can't have them there, so we want to know how to get rid of them. Alright, so let's go ahead and look at a few problems. Let me show you right away that the way I think of this problem right here, this 11 over 49, is I look at that fraction and I try to either divide or reduce the fraction. And if I can't, which I can't in this case, I like to split it into two radicals just like this, okay? And that's a legal move. I can do that. And then I try to simplify both radicals independently. Root 11 does not simplify, so I just keep it. Square root of 49 is 7. So I make that 7, and that's my answer, root 11 over 7. Number 2, I look at it, I try to simplify or reduce, and divide or reduce. Can't do it again, so I'm going to, again, split it into two radicals. And in this case, they're both perfect squares, so I get 5 over b squared. That is my answer there. Alright, let's look at a couple others that are maybe a little bit harder. Number 3 is a good example because I can actually divide here. So I'm not even going to split this fraction up. I'm going to divide 144 by 9. And I see that 9 goes into 14 once. And I'm left with 54, and 9 goes into 54 6 times. So that's 16. I have to keep the radical because I just divided underneath the radical, so it's still there. What's the square root of 16? That's 4. Okay, so that made that problem a little easier. I could have also split this into two radicals, like I did the first two, and I'd get 12 over 3. And 12 over 3 is still 4. So either way you do that problem, you get the right answer. Alright, let's look at number 4 here. 25p cubed, or the square root of 25p cubed over the square root of q squared. And this is going to give me 5p root p over q, just like that. Remember, p has an odd exponent, so I leave 1 behind. I'm down to 2, and I divide that in half to get 1. That's where that p on the outside came from. We can circle that if we want. And there's one more problem like this. Let's go ahead and split this one up because I can't reduce. So I have root 75 over square root of 16t squared. The square root of 75, I'm going to make a tree for that one. So I have 3 and 25. 25 is 5 and 5. I'll circle all the prime factors that I have. Since I have a pair of 5s, I end up with 5 root 3 as my numerator. 16 is a perfect square, that's 4, and t squared is t. So I have 5 root 3 over 4t. Alright, so if you have a radical underneath a fraction under a radical, you can always try to divide. If that doesn't work, split it into two radicals and simplify each radical independently to get an answer. Alright, let's say though you do that and you end up with something like number 1 here, where I have 2 over root 5. I'm not allowed to have the square root of any number in the bottom of a fraction. It's just one of those crazy math rules. So what I have to do here is multiply by the square root of 5 over the square root of 5. And where did I get the square root of 5 from? Well, it's whatever's in the bottom of the fraction. Okay. How did I know that I can multiply by that? Well, let me show you a couple examples here. Let's say I multiplied 3 times 1. What do I get? I get 3. Let's say I multiplied 25 times 1. That's 25. Okay. Let's say I had 100 times 1. Well, that's 100. Okay. My point is this: at any time I multiply by 1, I get that number back. So I'm allowed to multiply by 1 and it doesn't affect my answer. So let's go back to the problem. I chose to multiply by root 5 over root 5 because this is the number 1 in disguise. Anything divided by itself is 1. So I'm allowed to do that. Now, when I do this, I'm going to get 2 root 5 over the square root of 25. Okay? And that gives me 2 root 5 over 5 as my final answer. And now my square root is gone in the denominator, and so I'm happy. I've rationalized my denominator. Don't do this. When you get to this step right here, don't say, well, I can reduce this fraction, because this is going to undo what we just did. If you tried to reduce and make this 5 a 1 and this a 5, you're right back to 2 times the square root of 1, which is 1 over root 5. So don't do that. That's undoing what we just did. That's not good. We want to actually multiply and get 2 root 5 over 5. Alright, let's do the same thing with this expression. This time I'm going to multiply by root 8n over root 8n. Still 1 that I'm multiplying by. That gives me square root of 56n over 8n. Okay? 8n is really the square root of 64n squared, but that's 8n. It's just going to pop out what's underneath the radical. So the only thing I have to do is check this 56 to see if I can simplify that at all. And so I'm going to make a tree here, and you'll see that it simplifies here in a second. So let's see. So we see a pair of 2's. So we'd have 2 root 14n. There's a 7 and a 2 left. When you multiply, that's 14. That ends right there, so it comes over. We have this 8n under here. Okay, so we're doing some simplifying. And then if you're thinking about this, you might say to yourself, well, I can even go further. And you'd be right. Now that this 2 is outside of the radical, I can divide it by 2 to get 1, as long as I divide 8 by 2 to get 4. 2 over 8 is worth 1/4. So you're always simplifying. So we're left with root 14n over 4n. Okay? I can't reduce 14 over 4 because the 4 is not under a radical, but the 14 is. Same thing with the n's. So that's my answer right there. Alright, let's see here. Let's do 2 more. Alright. For this particular problem, it's one big radical, so I'm going to break it into 2 smaller radicals divided by, or the quotient of 2 smaller radicals. And then I'm going to multiply by root 10 over root 10. This way I can rationalize my denominator. It gives me the square root of 70m over 10. Can I simplify 70, or the square root of 70? I can't, so I'm just going to leave my answer like that. And I have one more problem here. I'm going to do this a little bit differently. I'm going to go ahead and break it up. But I'm going to recognize that square root of 18 is really 3 root 2 with the t in there, because you think about it, the 3 comes from the fact that we have 9 times 2 giving us 18. Then the square root of 9 is 3. And now to rationalize, I'm going to multiply by root 2t, because that's what's under the radical in the bottom. Okay? So that gives me the square root of 10t over 3 times 2t, which is the square root of 10t over 6t. And that's my answer. Alright, now let's go back here for a second. Let's erase some of this. Some of you guys might be looking at me like I'm crazy, so let's go back here. We'll erase that. And let's multiply. Let's not simplify, let's just multiply first. So let's make this root 18t over root 18t. Okay, well, what's that going to give us? That's going to give us the square root of 90t over 18t. And well, if we simplify that, that's going to give me 3 times the square root of 10t over 18t. Why? Because 9 times 10 is 90, and the square root of 9 is 3, so the 3 comes out. And then if you reduce, divide 3 by 3 and get 1, and 18 by 3 and get 6, you'll see that you get the same thing we just got a minute ago. So you can do it either way. It's up to you. And that's it.